All right, what can we do with this one right here? Now, we have a problem in that we have sine mixed with cosine, and there's no squares to split out. And so what we're going to do is we're going to apply the sine angle sum formula, which we've done before. So sine of two angles, let's call them x and phi, is equal to the sine of x cosine of phi. And the sine gets the sign right, so that's a plus cosine of x sine of phi. And the other thing is, since we have multiples out here with that addition, I'm going to put an a in front, which puts an a in front of each of these. Now, we're going to compare that right side. So ultimately, what I really want is this thing right here. I want it to look like that right there, because then I can solve this easy with an arc sine. So that's the whole point of this madness. Okay, so comparing these two, I want to compare this right side here to -6 times the sine of x plus 2 times the cosine of x. And so making some comparisons here, I have a sine of x here, and I have a cosine of x here and here. So what that tells me is that the a, let's switch color, that the a cosine of phi must be the same as -6, and the a sine of phi, that must be the same thing as 2 here. So I'm just going to write that down. A cosine of phi has to be -6. So I need to figure out what a and phi are. If we have two unknowns, we need two equations, and we got that. Other equation comes from over here. We also know that a sine of phi has to equal 2. Now, in the past, I've applied the Pythagorean identity to this. And if you do that, Pythagorean identity talks about sine squared plus cosine squared is 1. That, if you apply these two to that, what you end up with is the -6 squared plus the 2 squared has to equal a squared. Okay, so this conclusion right here is the result of the Pythagorean identity. So this is going to get me to find a. Once I have a, I can use the arc cosine to find phi. So this is going to give me 36 plus 4, which is 40. And so I want a, which would be the square root of that 40 there. So applying that to this, I can find phi. So now I have, and I guess I should clean up the square root of 40. That would be, we're just going to leave it. Square root of 40 times cosine of phi equals -6. So dividing to the square root to the other side, I get cosine of phi equals -6 over the square root of 40. And so phi has to be the arc cosine of -6 over the square root of 40. And I do often try to clean that up just to see if it's related to some special angle, but that doesn't look like it's going to be to me. So I guess I am going to double check. Let's see, 40 is 4 times 10. So then the square root of 40 would be 2 square root of 10. Yeah, that's not going to clean up. If we take -6 over 2 square roots of 10, 2 goes into 6, that gives me -3 over the square root of 10. And that's not one of the x or y values from the special angles. So all I know is theta is about that right there. All right, so what does that tell me? That tells me my original equation, the left side, can be rewritten as a square root of 40 times the sine of x plus this crazy value for phi. And since that's so messy, I'm just going to call it phi up here, and I'll deal with that in a minute. So that has to equal 3. And again, we know phi is this number over here, and we'll plug that in a moment. So to solve for sine, I just divide the square root of 40 to the other side. So sine of x plus phi is 3 over the square root of 40. And then thinking about, let's see how many solutions, first two, thinking about the sign on the unit circle, ignoring the x plus phi for a minute. And you've seen me do that before. I often ignore the inside and just think about the basic solutions first. So 3 over the square root of 40 is some small y value. So maybe let's say it's y equals about there. So one solution is right there. That's what the arc sine is going to tell me. So that solution right here, that angle, is the arc sine of 3 over the square root of 40. This other one over here on the other side, that's always going to be pi minus. So this other angle is pi minus that. Oops, arc sine. All right, so I'm getting closer. What do I know? Again, I apply the arc sine there, so that's going to give me x plus phi equals the arc sine of 3 over the square root of 40. Right, that's one of the solutions from the unit circle, the first one there. The second one is pi minus, so I also know that x plus phi is equal to pi minus the arc sine. Now I want x, which means I need to subtract phi over to the other side. So x, let's call that x1, would be the arc sine minus phi, and phi really is that arc cosine. And the same thing happens here. I need to subtract the phi over. So x would be that pi minus the arc sine. And then minus also the arc cosine. And then the other thing we have to check, since we're doing a subtraction to get those, do they end up actually being positive? And I have a hunch that this first one is going to turn out to be negative because that's such a small number, and then we're subtracting the value of the arc cosine. So let's see. So although on the unit circle they appear, that was before I subtracted that phi over, and that's going to rotate stuff in a negative direction. And I want positive solutions, so I have no guarantee I got the right answers there for several reasons. I could have made a mistake anywhere up to there, and then that plus phi is a rotation. That could throw things off. So we need to double check on a calculator. So we're going to do two things. We're going to look at the original expression, -6 sine plus 2 cosine. And we believe, let's zoom out, that that can be written as a single sine wave, and it looks like a regular sine wave. And we think that sine wave is square root. Actually, I'm going to type in that arc cosine number. I'm going to call it A. A equals the arc cosine. This is, maybe I should call it P for phi. Let's see, where was that in my notes here? Arc cosine of -6 over square root of 40. Arc cosine of -6 over the square root of 40. So that was that shift. Oops, parentheses, okay. And then we think that wave can be also represented as the square root of 40 times the sine of x plus this arc cosine up there. So I'm just going to call it A here. Oops, parentheses. And it's graphing it in purple. Let's change the color. think that's right here. Let's make you green, say. All right, so it looks like the green sits on top of the blue. Yeah, if I turn the green off, I can see the blue. So it looks like I did do that correct. All right, so next thing I need to double check are the solutions I came up with. So the first one I thought was the arc sine minus that value for the arc cosine. Okay, let's see what we got there. And I think that's actually going to put us into a negative number. So arc sine, oops, too many letters, of 3 over the square root of 40 minus that value for phi I have up here, which I'm currently calling A. It does end up being a negative number. Yeah, so that must be this solution right here. No, what do we want to know? We want to know when this is equal to 3. All right, let's graph y equals 3. Y equals 3. All right, so -2, that must be this number right there. Okay. So that subtracting that angle is throwing what I thought were my first couple of positive solutions into the negative realm. So my guess now is that that second solution that I found in my notes, this one might end up being -2 because from pi I'm subtracting 2 different things. So we're going to have to adjust. So let's go back to the graph, figure out which ones we want. All right, so the other solution I thought I had was pi minus the first solution, which I didn't give a name. I guess we'll call that B. So pi minus B is 5. Oh, that ends up being positive. I don't think I typed that right. No, it's not pi minus B. It's pi minus the arc sine, then minus A. All right, I guess I have to type it out. And then minus the arc cosine, which I was calling A. That should work all right. Yeah, -1.7. So that's probably this number right here. Oh, it's not letting me click on it. Come here. Zoom in. Nope. -1.7-ish. Yeah, it's somewhere in there. For some reason, Desmos is having a hard time plotting that. Okay, so that's -2. So I just need to shift those two over by the period to get the positive versions here and here. All right, so let's rename some things. Okay, so I thought my first solution was this one right here, but it's going to have to be 2 pi plus that, one period over. So I found this solution and this one. I want this one and that one, and they are a period away. And the period here, because we have just x's, is 2 pi. All right, so actual solutions, modify this. So I thought this x1 was my first solution, but that's in the negative area. So I need to add 2 pi to that. So there is one, that's the first positive solution there. And same thing here, that ended up being negative after all those subtractions. So I have to add 2 pi there too. So those are my first two solutions once I get them into the positive area. So this is definitely a tough problem. Doesn't look that bad at first. -6 cosine plus 2 sine. Doesn't seem too bad, but it is. And let's just test one of those to be sure. If I add 2 pi to this one and give it a name, let's see, I've used A and B. We'll call this one C. And let's name this f of x. I can just say, hey, what's f of that number? So that number is positive. F of C should be exactly 3. Got it. So my homework, accurate to at least 2 decimal places. One of the solutions is about, for my version, 6.11. And I get it part right because I didn't list the other solution. The other solution was this one plus 2 pi. 3.96, and we can confirm that on the graph, although Desmos is having a hard time calculating that. So it is in, let's see, oh, that's the other one, this one, 3.9 something. So again, Desmos is not able to calculate that. It's a little too hard for it, but that's about where I'm pointing. Yeah, that looks good, 3.96. Hooray. All right, and there's another video here if you need additional help.